Friday. I know we are on a different day this week. I just got back from traveling to Orlando like a few hours ago. So if I look really, really tired, it's because I'm really, really tired. So um, if you are here, say hello in the chat. Let us know where you are watching from. I'm not going to get cute this week with like telling you to comment something because, of course, I didn't prepare anything. So just comment, say hello, let me know where you are watching from. Also, I wanted to say this. If you are watching over on Facebook and you don't like that it comes up as Facebook user when I share your comments, just hop over to YouTube. You'll see us live over on YouTube. And over there, I can see all of your names. And it just makes it so much more fun to get to chat with you and call you by name. So I am here with my good friend Chelsea. I was like, okay, which way do I go? Chelsea from Will Teach for Taco. Was it Will Teach for Tacos? Yes. Goodness, she is just wonderful. This is like the first time we've like met online, kind of like it's not really in person, but online.
Yeah. I'm excited.
Yeah, super fun. Yes. Okay. So I am, for those of you who don't know me, I guess I'm Brittany Heggie. I am the math brain behind Mix and Math. And Chelsea, do you want to share kind of what you do, your teaching experience, what you do now, just all the things?
Yeah. So I taught math for 8 years. I taught a mix of 3rd, 4th, and 5th grade throughout those 8 years. And then I blog over at Will Teach for Tacos and share things on Instagram. I recently moved into the edtech space. So I'm working for an edtech company now that sells a math program that aligns very closely to my beliefs in how math should be taught. And yeah.
Yeah, we were just chatting about the program right before we got on. So I can't wait to like have a demo of it. But yeah, and she's got the cutest little kids ever. You've got 3, right? 3, 5 and under.
Yes. It's crazy world around here. If I might have to go on mute, if I do, it's because there's a lot of noise sometimes.
Yep, that is just the life of little kids. Oh my goodness. I've heard from other people, it's like as they get older, it's like different challenges, but I'm like, oh, don't tell me that. Like, just let me believe that it gets easier past this stage. So, okay, we've got.
Sleep, so I mean, that would be
Yes.
good.
Oh my gosh, if I could just get, I had like my first 6-hour chunk of sleep within the last 12 months, like last week, and I was like, it was glorious. I think my body didn't even know what to do with 6 hours of sleep. So, okay, let's say hi. Deanna's here. We've got Kendra, Denise, Gina, Patricia. Oh, thank you so much. Yeah, I don't usually wear my hair curly a whole lot, but there's something about like traveling in the car on a road trip. Like you just get out, and we don't usually, we do eat out a lot, but not like some of the places we ate on a road trip. By the time I got home, I was like, I just need to shower. So you guys get the wet curly hair. Okay, let's go ahead and get started like we usually do by sharing some of your aha moments. We had some great aha moments this week. So Janine said, teaching place value has to go so much deeper than how much a digit is worth in each place or adding a zero or counting the decimal places. Students must recognize the multiplicative relationship between the digits. So much of the 5th grade curriculum is based on this understanding. I'll be referring back to this a lot. This is big. I feel like a broken record sometimes when I'm talking about place value because so much, if you go like on TPT or you just really search anywhere for place value resources, a lot of it is like, what's the value of the digit in the tens place? What's the value of the digit in the hundredths place? And I'm so glad that this chapter just highlighted like how much we need to go deeper with this concept. Okay, Michelle said, one of my big ahas is the connection between measurement problems and comparison. We struggled with conversions this year, both in base 10 and in metric measurement. I need to make the connection between these types of problems for my kids and get them acting it out more with real life situations. I absolutely love this. I think we talked about this a little bit before we got on. I don't know if you shared this, Chelsea, at the beginning, but Chelsea's in Texas. So that means that like all of the standards are different over there.
We do what we want.
Exactly. Yes. So yeah, we're going to actually talk about the connection between measurement conversions and multiplicative comparison. Jamie said, I never really thought about this being the beginning understanding of ratios, just another multiplication problem. If we don't give them a very solid foundation, with this, not only will junior high math be a struggle, but adult math too. So many things we do in adult life involves this kind of thinking. Yes, absolutely. We talked about that before we hopped on as well, and we're going to continue to talk about that. But I do love, and maybe this is, oh, no, I don't think I added this comment, but somebody said, that the authors talked about how they're building this type of thinking even into adulthood. And I loved that because it shows that like it just takes time, but also there are so many adults who struggle with this as well. So last one that stuck out was from another Jamie, and she said that all students need to have access to problems of this type intermixed with the more easily accessible equal groups types. So often multiplicative comparison problems are taught in isolation and then later in the year. And when these problems come back, her students are stumped. Students don't seem to know what to do with them. So I think giving these types of problems early in the year and continuing to expose them to this type throughout the year would be beneficial. So awesome. Absolutely love that aha moment. Okay, so remind me, in Texas, you said this was a standard multiplicative comparison. Did it start in 3rd grade or 4th grade?
3rd grade, I believe. Yeah. I'm pretty sure it's like its own standard in 3rd grade. Which is probably why we always teach it in such isolation instead of like mixed in with other,
Yeah, it is really interesting because, and that's a really good point. I do think a lot of times it's taught in isolation because it is its own standard. Even in Common Core in 4th grade, it is. And I think it's its own standard because it's a very different type of thinking. But that doesn't mean that it's like you teach it once and like that's it. Like it's not later incorporated with all the other multiplication problems. So I do love that the authors talked about like mixing it up or mixing those in a whole lot more. Okay, so let's go ahead. We're just going to kind of go through this chapter and talk about some of the ahas that we had, things that stood out. This chapter I felt like was really heavy with a lot of like problems and models and all of that. So we'll talk about quite a bit of those. My mother is texting me, so let me put my computer on Do Not Disturb. So we're going to dive into some of those. So let's start with this. Let's see. I think the first one that I would love to start with, and I'm actually going to kind of jump around a little bit, is this very first problem. I think it's on page 141. So if you didn't do the moving beyond whole numbers one, this doesn't really have anything to do too much with like fractions, although it can be. But the problem on page 141, it was figure 7.18. Oh my goodness, y'all are gonna have to deal with a very sleep-deprived, exhausted me post Get Your Teach On. But this problem, so in this problem, they basically said like Lauren has a certain amount of money, Kimmy has a certain amount, and they each get $3. Whose balance grew the most? And I just thought this was such an interesting problem because for me, my brain immediately went to like just like an additive way of thinking. And Chelsea and I talked about this, and your brain went more the multiplicative route, right?
Well, I feel like initially I was like, well, they both just have 3 more than whatever they started with. But I knew like it couldn't just be that like basic. There had to be more to it. So once I thought about it a little bit more, that's where I went. But initially, no.
Yeah. And so I think that even us as adults, like I feel like I'm relatively like strong in math. Like I talk about math a whole lot. But I still think in certain situations, my brain goes to more of like an additive comparison like type situation versus thinking multiplicatively or like thinking about relative change or anything like that. So I do love, we obviously in this book study skipped like the adding and subtracting chapters. But I do love like in the very beginning, they give us that first problem on page 130 that really showed the difference between, what did they say? Additive comparison and multiplicative comparison. And what's interesting too is like, I feel like if you don't teach lower grades or don't have experience teaching lower grades, like you probably aren't thinking as much about additive comparison and how it's different than multiplicative comparison. But the language, it's so similar. Like it's just like a tiny nuance in changing like how they worded it. What did they say? They said like, what is it? Like 3 more than, or like 3 times further than. Like it's not very different for students. And so it requires like a ton of modeling and experience and like exposure to this, I think. Okay, let's see. What can you give me like something that stood out for you on like kind of in that early part of the chapter? What was something that you underlined that you were just like, oh, That's like an aha moment for me, or something that maybe you see like in your classroom.
Which, and it kind of connects to the problem you were just looking at with the piggy bank and the money, but I highlighted using sum in place of the quantities. So I told you if they had put numbers in that problem, I would have been like so confused. So the fact that they left the numbers out really helped me to like understand and think about the problem, because I couldn't just like jump to trying to calculate it, which is what I would, do as an adult. And I know my students would absolutely do. So I think that's really powerful, I find it especially helpful when students are working with fractions and decimals, because they're just like more abstract and harder to think about. So I feel like using sum in those word problems is really helpful for students.
Yeah, and I feel like that's been a theme kind of across this book, is anytime it's like we're trying to really get them to understand the problem, like using that word sum and not allowing them to quickly jump to like operating has been really powerful. So yeah, I really like that as well. So, okay, let's look at page, what is it, like 133. So the multiplicative comparison, they said a problem situation that compares two measures by describing their difference in terms of how many times greater or less than one is than the other. Okay, so this is interesting. When we were talking, you were saying like that term 10 times less than stood out to you. It was like, oh, like that feels so backwards for students, because students think that a lot of times they think multiplication only makes things bigger. And so to think multiplicatively in the opposite way and think 10 times less than can be a struggle. Did you said you usually use the language like 1/10 of?
Yes, which I mean isn't any more clear, because usually the standard, at least for us, is like at the beginning of the year. And so we haven't done fractions. So like even saying the word 1/10 is not easy, but definitely saying 10 times less just seemed like contradictory to say 10 times and then less. Yeah. In my mind,
Yeah.
especially in students' minds. Yeah.
Yeah, exactly. I thought it was really good. And yeah, I think the same thing, because so it was obviously a fifth grade standard for us. And I used 10 times less as kind of like transitional language. And then we moved into like 1/10 of. Okay, Rhonda said she uses 1/10 of or 100th of as well. Yeah. I think sometimes the fraction language can be intimidating for students. If they have the foundation that we want them to have, it wouldn't be intimidating. But I think early in the year it can be. But yeah, I think to me, if we're talking about like modeling it out, like the picture that they drew on page 137, figure 7.12, like to me, that like shows 1/10 of. Like it makes sense that you're splitting it up into tenths and you're taking one of those parts, which is kind of what we talked about maybe 2 weeks ago, I believe. Okay, and then Patricia said seeing a definition for scale factor for the first time was really important. So the scale factor, the factor that describes times as many, is often referred to as a scale factor, and the action as scaling. Yeah, I thought this was really good as well. Especially, this can be so challenging for, like, scaling up is not necessarily challenging for students, but then like, is that really even the right way to say it? Like scaling up and scaling down. But when we're scaling by a factor that is less than one, I should say, that is when it gets really, really challenging for students. And that's when we see that with multiplying fractions for sure. Let's see what the Ignited teacher said. She said, knowing the difference between additive and multiplicative comparison is important for algebraic reasoning at a secondary level. The problem I've always seen is that 4th and 5th grade teachers allow their students to use repeated addition when they're supposed to use multiplication. Okay, so this is a really, really good comment, because she talks about how if we are only viewing multiplication as repeated addition, which I feel like we've talked about, it was either last week or the couple weeks ago, we're missing out on multiplication kind of as a, like, I don't know, as finding part of a group or finding like that scale. And that is like, it's a big jump for students, but it's something that they definitely, like, they need to get to that point of seeing that. And they're very different situations. The repeated addition. We actually just talked about this too, because we were like, okay, 6 times 1 1/3 is very different than 1 1/3 times 6 in context as well. So yeah, great point. Thanks for sharing that. Okay,
and then Rhonda also commented that 10 times less causes her kids to go to subtraction immediately. And I would definitely agree. That's, yeah.
So 10 times less causes students to go.
Yes,
okay.
We're going to talk about that.
Yes, let's definitely talk about that, because it's it's like all in the language. This is where I think it's really, really hard for students. And I think maybe why it requires like so much um, like exposure, because 10 times less, or even I was thinking about growth. Like if we're thinking about like a business, like on Shark Tank, when we're talking about growth, and some businesses will say like, I grew by 125%. And that's different than I had 125% growth, because that one is you increased by 25% versus like if you say you increased by 125%, that means like those are two very different things, I should say. And so it's like it's even like this nuance in language that even adults kind of struggle with sometimes. And I don't know if I said that right the first time. Increasing by 125% is different than having 125% growth, right? I don't know. See, I've even confused myself. So yeah, and I think with students they struggle with it as well. And I don't think that just because they're struggling with like the language of it necessarily means that they don't understand the relationship. But I think that's why it's so important that we assess them beyond just like, did you get this problem right or wrong? But how did you represent the situation? What is the language that like, how are you explaining your thinking? Just looking at it a whole lot more in depth than just like, did they get this right or wrong? Because like I said, even as adults, we struggle with some of this language. And the teacher in one of the commentary was struggling with like, wait, do I really understand this? Was this right? Was this wrong? So yeah. Lisa said, I have found models and pictures help the students see the relationship so much easier in place value in fourth grade. The 1/10 of is a struggle for them, even with the models, though. For sure. Absolutely. There was a question about, and I'm going to see if I can pop it up. I think it's this one. Nope. Okay. It was this one. So Sheila asked about, she said, I wonder, she said, essentially, she said, like, is the fourth grade standard for measurement conversions when they go from larger units to smaller units? Is it only that in fourth grade? Because that requires multiplication. And then in fifth grade, going from smaller units to bigger units requires division. She was asking if the reason they split those up into grades is because division is harder for students than multiplication. And I actually think it is because I was working on some measurement conversion resources, and I think the models are so much more challenging. Like if we're starting with like a larger unit and we're representing it with smaller units, we're kind of like showing all of the smaller units into that like larger one, versus like the opposite way. I was trying to create like a really hands-on concrete way to get students to explore this. We're basically having to like take all these smaller units and like break them down and group them into like a larger unit. So I just think the thinking behind it and the model behind it is so much more challenging. And I think that kind of goes along the same thing with place value as well. Like it's easier to kind of go the other way than to think about it as like 1/10. I don't know. Has that kind of been your experience in working with students?
Yeah, definitely. Because I feel like, yeah, the 10 times greater seems to make a whole lot more sense than the 1/10. But it also might have to do with, like I said, we usually teach at the beginning of the year. And so our fraction foundation in general is not super strong then. So like, yeah, I feel like that probably has to do with it as well. Just understanding what 1/10 even, like, what does that even mean? So
yeah, absolutely. And so again, Patricia said, like, if things are worded weirdly, like talking about the language of it, it's like we're trying to talk about and explain this with language that either doesn't feel clear, or like students are having a hard time like visualizing how we're explaining it. So like when we say 1/10, like what are they picturing in their head? Which absolutely goes to the fact that it's like we have to be modeling these things. We have to be like showing this with some type of representation in addition to the verbal representation. Rhonda said the use of keywords throw them off. Would it help to show them with a greater than and less than sign? I'm not sure I 100% know what you mean, Rhonda, as far as the greater than and less than sign. I'm not sure. If you want to clarify, that'd be great. So, okay, something that I underlined was, this is where we need to talk about this whole, we said we were going to dive into this, the whole place value understanding. So I underlined the part that said relative thinking and place value. I'm on page 136, middle of the page. Relative thinking and place value are at the root of our base 10 system. Each place value is 10 times greater than the one that precedes it. And in decimals, 1/10 is 1/10 of one. I kind of like paraphrase that. Understanding this concept is not the same skill as recognizing, identifying, and naming the value of each digit in a number. I think that is so incredibly important for us to understand. And I think we see this in students, like even when we think about something as simple or straightforward, like I don't want to say simple, but it seems simple compared to multiplicative comparison, like regrouping. Like that is when we think students have an understanding of place value because they can identify like, oh, the 4 in the tens place has a value of 40. But when they go to regroup, they have no idea how to regroup. And that's when we're like, okay, they clearly don't have an understanding of our number system, our base 10 number system. They are just like, I don't know if like rote is the right word there, but they just have memorized like, oh, this is the place, this is the digit in the place, so has a value of whatever. So I love that they pointed out that it's so important to go so much deeper than that. Somebody actually asked a question about this, and I'd love to hear, Chelsea, what you've done. So Anita said, what have you found to be the best way to model 10 times more, 10 times less than? And then which goes along with, how do you help students understand the why behind adding a zero? So has there been anything, like just even one activity that you've done that has been successful with your students and kind of helping them model the 10 times greater, 10 times less than, or the whole like, why do we add a zero when we multiply by 10?
I mean, we use the place value flags, and we would like write like 40 and then have the place value desk or place base 10 blocks or whatever, and then do 400 and then do the same thing. And we talk about how do we get from 40 to 400, and that 400 is 10 times greater. But it's definitely not the easiest thing for students to understand and grasp, especially, I mean, the language around it is so challenging.
Yes, for sure. And so Patricia said she's used the place value flags as well. So for those of you who don't know what the place value flags are, so those are one of the resources in Mix and Math 360. And so what it is essentially is like, what do we tell students? Like when we multiply by 10, you add a zero. Or maybe we don't tell students that, but that's what they've heard. Or when you multiply by 100, you add 2 zeros. And so we want them to really understand what's happening. And we see this a lot too with decimals when people are like, okay, well, when you divide by 10, you just move the decimal to the left or whatever. And so it's these little like place value flags, and we put them on popsicle sticks. And essentially you have like your number tiles. And so it's like, well, what happens to, the 3 in this place when you multiply it by 10? Okay, well, it becomes 30. So what would happen? Well, all the numbers are shifting places. Like you would move that 3 from the tens place to the hundreds place to represent 300. And eventually they recognize that it's the numbers that are shifting places because the values are increasing. They become 10 times greater. And then we can show kind of like why we do the whole adding a zero or moving the decimal, because it's really an easier way to help us shift those numbers places. So it's kind of hard to, I guess, explain. It would be much easier if I could represent it. So, okay, I lost my place in the book. Let's see. Do we want to dive into measurement conversions and how this relates?
Sure.
Okay. So when we're talking about, I want to see what chapter, what page was this on? I had underlined
one
part of it.
139, maybe?
Yep, it's right here. So it says conversions between units of measure require multiplicative thinking as students visualize and calculate how many times greater or less than one unit of measure is than another. So I love this. If you've not taught multiplicative comparison through measurement conversions, I highly recommend it because it's to me, it is language that comes so naturally. I think sometimes like somebody had asked a question about the cat situation at the bottom of like 147. And in that example, they talked about like 1 1/3 as many cats or something like that. And the language just felt confusing and out of place. And so when we're talking about a concept that already can be challenging, I feel like we want to expose students to it in a way that is like the most maybe authentic, or like when we would actually use like multiplicative comparison, like in that situation. And to me, measurement is like the perfect situation, because when we are talking about it, like we do talk about the fact that a foot is 12 times longer than an inch, or that an inch is 1/12 of the length of a foot. That makes sense. And so if we can build students' understanding of this concept in situations where it makes sense, I think we'll be much more effective, and we won't run into a lot of this issues with like the nuance of trying to figure out, like, are they looking for an additive comparison here or a multiplicative comparison? So I actually just shared a reel, I think over on Instagram, that was showing this. If you've not used blank fraction tiles, I love them for showing multiplicative comparison and also for measurement conversions as well. They're essentially like a concrete version of a like bar model or a tape diagram, essentially. And if you have, I usually write on them with dry erase markers. And you have to like really use like a wipe or something to get it off, but it's really like a concrete version of a tape diagram. Do you have any representations that you've used with students for multiplicative comparison?
Well, I mean, just I was going to tell you something I did wrong, or that I wish I
Well,
had
share
done.
that. Yeah.
So on that next page, which I actually highlighted the exact same sentence you did, but on the next page on 7.16, I just put that I wish I had used something like, I taught measurement conversions very procedurally, and I'm not saying like I know that that's not, I feel like the biggest not complaint, but like thing that just keeps being talked about is the amount of time we don't have that we need to conceptually teach these things. And so measurement was like usually one of those things at the end of the year, like we're getting close to state testing. And so like I had a procedure that worked for students that probably didn't, like it wasn't something that stuck with them in the long run, I'm sure. And so I just wish I had used more concrete things. Like I'm thinking about it like in a strip diagram, like here's a foot and then here's the 12 inches, or using the blank fraction tiles like you're talking about. So just things that I wish I'd been like just shown more concretely to students. Like that was a unit that I never really and it lends itself to being concrete. Like we have literal rulers in our classroom, and I just didn't, and I should have.
But I think that goes back to, like, we talk about this all the time about the fact that like we as educators like are still in our own growth journeys as well. Like literally looking at this, because I will say like I never deviated like outside of like a bar model or using those blank fraction tiles. And it's like, I feel like we need to expose ourselves to more like different types of models or different ways that students might approach it, and then provide those different opportunities for students, or even show students a variety of ways to do it. Because like some of the models that they used here, like I would have never thought to do. But we don't know that if like we're not exposed to it. And also our students won't do it either if we don't give them the tools to do it. So I love that you pointed that out. I think this book has used square tiles way more than I've ever thought to use them in 4th or 5th grade math. So, okay, this is an interesting comment. So I see a comment about the term regrouping being unclear, and that using the word trade instead. So I actually love the term regroup, and here's why. Because when we're talking with students, like we want them to recognize that our base 10 number system is essentially like bundling or unbundling like groups of 10. And so if we're using that language of bundle and unbundle, or if we're talking about like grouping and ungrouping, Daylene's in the comments.
So much.
Daylene's so excited to have Chelsea on. Welcome, Daylene. So glad you're here with us. So anyways, so if we're viewing our base 10 number system as bundling and unbundling these groups of 10, or grouping and I guess like what would be ungrouping? What's the opposite of like grouping then? I don't know. Anyways, they're groups of 10 essentially. So, but I can see how the word regroup would be confusing to students who don't truly understand place value, who don't recognize that our place value is built on groups of 10. So, okay, let's see what Rhonda said. She said, I have created 2 worksheets for students to measure items around the room. One version would be measure in inches. The other would be measure in feet or similar. Then we would compare answers. Absolutely. Okay, so this is a great activity, and here's why. Once you go to compare answers, you're seeing that multiplicative comparison right there. Because just because something like is, I don't know, say you measure something in feet, and the other one is 3 feet longer, that does not mean that in inches it's going to be 3 inches longer. It's going to have like, that multiplicative relationship. So I love that. I think that's a very simple, straightforward way to get students, one, practicing those measurement conversions, but also having that multiplicative comparison. Compose and decompose in place of grouping and regrouping. There you go. I think that's what I was working. We're talking about like decomposing it, which is really helpful when we get to fractions as well. Okay. Let's see here. Was there anything else that we had talked about pointing out? Again, I think this is really good. I think this chapter just reiterates kind of what we had said a few chapters ago when talking about our measure factor and our multiplier factor here, that they have two different jobs. We have one that is showing, like, if we're talking about length, one that's showing the length and the other that's showing the, like, I guess, comparison to, so like 7 times longer or 7 times heavier or whatever. So I like how these chapters just kind of like build on each other. Anything else that you underlined or highlighted that we didn't necessarily dive into before we go into like the moving beyond whole numbers section?
I feel like, I don't know, our conversation before and this conversation are kind of like mushing together. I think I covered everything I highlighted.
Okay, perfect. Let's answer some of the questions and then we'll dive into, because I really want to talk about the whole absolute change and relative change. Okay, so let's answer some questions first. So Trisha said she didn't quite understand the figures 7.18, 7.19, and 7.20. So let's jump there. That is on page, I guess that's, hold on. I guess this is technically moving beyond whole numbers. So we'll come back to that if we have some other ones we haven't talked about. We talked about that one. Okay, this was a great one. So Andrea talked about if she has a student who is maybe using the algorithm for 10 times 4/10, should she let them just keep going, or should she stop them and help them realize that there's a more efficient way to solve the answer? So these are my thoughts. Obviously, y'all are welcome to have a different opinion. My thinking is, like, I don't know that I would necessarily stop the student, but I definitely would kind of like lean in afterwards and be like, okay, like, what patterns do you see? Like, what did you notice? Connect it back to maybe an experience that they've already had. I don't know. Me personally, I'm not a huge fan of like jumping in and stopping their train of thinking and trying to redirect them, instead of like maybe even asking a question as they're doing it. But I wouldn't just outright be like, nope, let's change directions. Because my hope would be that they would realize, one, that it's really inefficient, and two, once they see the answer, they might be like, oh, like, I totally could have just done this. So what do you think, Chelsea?
Also think it depends on like what, like, is this something we've already like taught and they just forgot that there's like a easier way to do it, or like, so I think there's like some other factors that could play in here. But I was also telling you, like, I feel like if my students were doing the algorithm for that, like, they would mess themselves up with, I don't know, zeros, always mess up my kids, figuring out where to place the decimal. And so, like, yes, it's less efficient, but like, it also might be less accurate. Like, if you're not even, doing the algorithm correctly.
Yeah, absolutely. And then also too, I've done this as well, especially like working with a small group of students, is like, if I see something that is like inefficient, either one, if I have like another student in the small group who's maybe did it in a different way, like getting them to compare their thinking, or if they, like, there isn't another student in the group who's doing it in a more efficient way, I might solve it and be like, oh, this is how I solved it. Here's kind of my thought process behind it. How is this similar to what you did? Like, how is it different than what you did? So that's another thing too, just getting them to compare different ways of solving as well. Okay, we had another question that I wanted to dive into. I think right up 4th grade. Okay, I think that's it. So let's jump into this question, and then we are actually going to move into talking about the moving beyond whole numbers section. I still think that this is really relevant, even if you don't necessarily teach fractions, but to know where students are going with this, because you may not recognize that, I don't know, just like some of the language or whatever that we use in grades before these fraction concepts can really set our students up for success, or maybe like cause some misconceptions unintentionally later on. So With this one, Trisha said she didn't understand figures 718, 719, and 720. So let's take a look at these. So this was the one that I kind of mentioned at the beginning, but we didn't dive into, where they weren't super clear on what they were looking for here. When I first saw this, I totally thought about I love the language that they gave us, absolute change and relative change. I totally thought about this in absolute change. Like both of them grew by, what was it, $3, and that was it. I think, Chelsea, you said you thought about more relative change, right?
Yes. Yeah.
And that was because they didn't really give you any other numbers to go off of. And I just thought that was really interesting. So the models here are just showing. So the first one, 719, is just showing I don't know that she actually technically represented it right, because I think it was like she had $4 and she added by 3. And then 720 is just showing a lot of money, because they didn't really tell us how much Lauren had. They just showed a lot. So 720 is just showing a lot, and then plus 3, versus, I guess I don't understand 719. I think she's just showing that they both grew by $3.
Yeah, I think
yeah, that's what it is. They both just got 3 more, and she's showing that they're equal.
What did the question actually say? It said, whose balance grew the most? So she's saying that they grew equal amount by $3.
Yes, exactly. Yeah. And then 720 is showing a lot of money on one side plus 3, and then just a little bit of money plus 3. So yeah, I mean, that's really what those models are showing. I really liked how whatever student 2, did they give a name to student 2? I don't think so. But I do like how student 2 approached this and was thinking about the relative change. That was not my initial response at all. But this is what we had kind of talked about too. I think that it depends on the situation. And not to say that this is not a situation where you think about relative change, but when we're talking about like the cats problem, for example, on page 147, because this Trisha also talked about 147, like a lot of times, like in that situation, when we're talking about a woman in her home with cats, like we're not necessarily thinking about relative change. Like we are thinking about absolute change. Like how many more cats does she add to her house? Whereas if we're talking about a business on Shark Tank, they are not concerned. The sharks are not concerned about the absolute change, because they have people who come in with various like levels of success with business. They don't care whether you grew by $200,000, because $200,000 is very different when you're a $50,000 company versus a $3.5 million company. They want to know your relative change. And so I think to some extent, like some of this, like I don't know, I go back to, I think we just have to be intentional with the situations that we are exposing students to, and like what's natural there. Like I don't know. I don't believe in like forcing it. Like the whole cat problem, I totally understand like what they're saying there, but that's a situation to me that feels very forced to talk about relative change.
I think just allowing students to like justify, because maybe they were thinking about it differently than what you like. We just posed that question, which I don't think we would. We talked about that a little bit, how it's not like necessarily in 4th or 5th grade, but like maybe they were just thinking about it. Like it's not that they were wrong. They were just thinking about it differently than we had initially wanted them to, or what we were intending to get to.
Yeah, absolutely. And I think like, I do like giving them questions that are open and letting them interpret it how they want and show us like their thinking and justifying their thinking. I love that. We talked about that with the pencil problem. The pencil problem where it was like, how many more pencils do you need to buy for next time? Like, I love how open it is. I love that it requires students to justify their thinking and for there to be some type of like discussion around that. But I don't know. If in thinking about like working with 4th grade students or even 5th grade students, I don't know how I feel about using the words like absolute change or relative change. I kind of to some extent feel like maybe those are like adulty words at this point. But I do think it's really important for them to like start thinking about the difference in how you're comparing that change. Patricia said, how can you have 1/3 of a cat? Yeah. Okay. So this was, I feel like I've said this like so many times, but this is where it goes into the whole like nuance of the language, which is what makes it so hard for students, because she didn't technically say 1/3 of a cat. They said she has 1 1/3 of the number of cats, which is different than 1 1/3
Of a cat.
cats. Yeah, but if that's easy for us to overlook as adults, like how much more challenging is that for students?
Yep.
So again, it goes into I don't yeah, I mean, these problems I think are ones that you really have to like dig into. They're not ones that are just easy to like if we're just expecting students to read through them and solve them like without I don't know, actually like diving into it, thinking about it, representing it, like I think it's easy for students to make mistakes with this and to think about it in more of a, like Rhonda was saying, with subtraction versus finding 10 times less than because the language is so similar. Patricia says, oh, I see that now. Okay, Facebook user said, I absolutely went to relative change with the money example, but I agree the question could easily be interpreted differently. I saw the absolute change afterwards and thought, oh, yeah, should have seen that first. Yeah, it's so different. And I think it depends on, there's so many factors that go into it. It depends on like what you think is being expected out of the problem, like maybe a recent problem that you just solved. Like I go back to the situation. To me, I think the situation determines kind of how you initially want to interpret it. Yeah. Okay. Let's see. Anything else that we need to go over? I think the last few things that I kind of highlighted from this on the key ideas were one, number two. I really like number two that was talking about just this job of the two factors. I think that's really important. And then number three, when measuring, students should recognize that the same object can be measured with two different units, thus having the same measurement but with different values. I think this is huge. If you have not, go over to my Instagram, watch I think it's my most recent reel. It's the horse and fly one, which I learned that a lot of teachers have never heard the saying about horses and flies for measurement conversions. Have you heard it?
Yes, yeah.
Okay. I had
emotions with it and everything. I just can't.
That is so funny. Yes, so many teachers were like, what are you talking about, horses and flies? I was like, it's like a measurement conversion chant that I remember somebody teaching me like my first year teaching. So definitely head over there because one, you'll see just more conversation about measurement conversions, but you'll also see how I use the blank fraction tiles to show measurement conversions, and it'll be the same thing for multiplicative comparison as well if you're wanting to model it with those. Patricia says it has to include the motions. I didn't know there was motions, so I missed out on that. Okay, and then last was that I circled was just multiplicative comparison represents relative thinking. The difference between two values depends on and is related to the actual values. So I thought this was a really good chapter. I thought they did a great job of like highlighting the importance of multiplicative comparison. And I think it definitely opened my eyes to the fact that we're like not including it enough a lot of times in the classroom. And also just the variation in models. Like the way that they represented some things, I was like, I would have never thought to do that. So kind of my big takeaway from this is going to be, I'm definitely going to be playing with some different models for this and seeing like what I can do to incorporate like things outside of like your go-tos. And that's actually kind of where I struggled when I was thinking about, I kept using a lot of length models for multiplicative comparison and measurement conversions. And when I was trying to do like things for weight or capacity, like, yes, you can still do length models, but I was trying to do something that was a little bit more authentic or like maybe match the representation a little bit more. And I was like, oh, this is challenging. So this is an area of growth for me, 100%. All right. Anything else? Any questions that y'all have? This is a pretty quick and straightforward chapter. We will dive in. If you haven't, I was super late in posting everything this week. Like I think I posted everything midday just because it was such a busy week and I was out of town. So if you have questions, be sure to post if you didn't see the post. Be sure to post them. If you did the moving beyond whole numbers, be sure to go back and add your questions there as well. And I'll definitely be jumping in after I recuperate this weekend to answer your questions. But if nothing else, let's go ahead and close out. Chelsea, tell me, I'm going to add your handle. So where do you want people to follow you at? On Instagram or Twitter? Because I feel like you're like doing Twitter now too.
Yes. Yeah. But Twitter's going to be more like ed tech stuff. So if you're interested in what I'm doing now, definitely Twitter, but Instagram for just I'd say math content, but there's a lot of live content too. So if you want to see my cute kids, Instagram.
Yes. Okay. I put it shows up under mine, but you can follow Chelsea over. Did I put that? Is it 4 spelled out? Okay. Perfect. You can follow Chelsea over on Instagram at Will Teach for Tacos. Awesome. Next week is our last week. Next week is like a recap of everything. And there are some really good like question, like Q&As. That's really what next week's chapter is. There's a section of Q&A and it's really good. So I'm super excited for us to like close out, break it down, all of that. Thank y'all so much for joining live tonight. If you watch the replay, make sure you comment replay and let me know. But we will talk to y'all soon. Thanks for joining.